Dear friends, welcome to my YouTube channel, Mathematics and Statistics Clinic, a channel dedicated for the service related to teaching learning activities in mathematics and statistics. This is Indra which happy here, a career educator. People love to address me as Dr. K. Today in this video, we shall discuss the inverse normal distribution, also known as quantile function or probability function. The inverse normal function takes probability value as input and returns the corresponding value on the horizontal axis of the normal distribution known as the quantile of the normal distribution. In my previous video, we discussed how to find the probability of certain normal random variable falling in an interval of the horizontal axis of a normal distribution. We use the area property of the normal distribution to find the probability something like this. Probability of G square lying between negative 1.42 to 0.96 is this area. The probability is 0.7537. That is 75% of the area lies within the interval from negative 1.42 to 0.96. Today, we shall discuss inverse probability with a focus on the same area property but in the reverse order. That is, given the probability, we shall try to estimate the value of the corresponding random variable along the horizontal axis. That is, this probability is given. We shall try to find out this value, a random variable on the horizontal axis of the normal curve. First, as an example, we shall consider quartiles of standard normal distribution to start our discussion. Quartiles, as we know already, are the 3 points on the horizontal axis of a normal distribution that divide the whole distribution into 4 equal parts as shown in this figure. These quartiles, denoted by Q1, Q2, and Q3, are first, second, and third quartiles respectively. By definition, these quartiles Q1, Q2, and Q3 locate the positions on the horizontal axis that has the share of 25%, 50%, and 75% on the left side of the curve respectively. That is area under the normal curve or the probability. Our problem here is to find the values of these location points Q1, Q2, and Q3 respectively on the horizontal axis as defined by this probability equation. That is, this probability P is given and we are trying to find out this value Q from this equation. That is, probability is 0.25, 0.5, and 0.75 are known. The problem here is to find the values of these Qs, Q1, Q2, and Q3, the location points on the horizontal axis of the curve. Let's proceed to find these quartiles using different techniques such as Z-table, statistical computing software or Excel, TI calculator, and my website www.teachumath.com. Among these resources, I think the easiest one to start with is to visit my website at this link. This is the page This is the button for self-generation of quantiles. If we refresh this, different quantiles for different distribution can be seen in the display panel here. Since we are computing quartiles manually, we select this button, normal quantile manual. Let the mean 0 and standard deviation 1 as it is. In the probability input box, the default value 0.5 is for second quartile. The value 0 can be seen in the display panel. Change this 0.5 to 0.25 for the first quartile. The first quartile value, negative 0.6745, is printed on the display. Next, change this value 0.25 to 0.75 and note that the third quartile 0.6745 on the display panel. This is how we can find quartiles of standard normal distribution using my website www.teachumaths.com. Next, we shall discuss here the use of technology such as R, Excel, and TI to find the quartile. First, let's discuss R. The R command is qnorm with the arguments probability, mean, standard deviation, lower tail, etc. as shown here. In the present case, we have the command qnorm with probability 0.25 for the first quartile, 0.5 for the second quartile, and 0.75 for the third quartile. If we copy this command and paste at our console and enter, we get the first quartile. And if we change this probability 0.25 to 0.5, we get the second quartile, and with 0.75, we get the third quartile. Similarly, Excel command is norm.in with the argument probability, mean, and standard deviation. For first quartile, here we have this command normin 0.2501. If we copy this command and paste any cell of Excel, we get the first quartile. If we change this value probability to 0.5 and enter, we get the second quartile. And also, if we change this value to 0.75 and enter, we get the third quartile. To get the quartiles on the TI calculator, we press two buttons, second values. This leads to a menu screen. Press 3 in norm, where we input the following information: area, mean, and standard deviation. Area, that is probability 0.25 for first quartile, 0.5 for second quartile, and 0.75 for third quartile. If we input all this information in the output, we get the value of first quartile, second quartile, and third quartile as shown here. In the last step of the discussion, we shall consider a traditional method, that is use of z-table to find the quantile values. Here is the table. In this method, we try to search a number inside the body of the table that either exactly matches or the nearest one to the given probability. When this number is located inside the body of the table, we read the z-value corresponding to this number from the first column and the top row. As an example, let's start to find the second quartile corresponding to this probability equation. Probability z less or equal to q2 is equal to 0.5. Here in this equation, 0.5 is the given probability and q, the second quartile, we try to find. Let's try to sort a number inside the body of this table that matches with a number 0.5. Here is the exact match, 0.5000. The corresponding z-value of this number is 0.0. Hence, second quartile is 0. Next, for the first quartile, we try to search a number inside the body of the table that matches with 0.25. Here we find these two numbers, 0.25143 and 0.24825. containing 0.25. The corresponding G values of these numbers are negative 0.67 for this number and negative 0.68 for this number. The average of these two G scores is negative 0.675 is the first quartile. Because of the symmetry, we find these two numbers 0.74857 and 0.75175 that contain 0.75 with G values 0.67 and 0.68 respectively. The average of these G values is 0.675 is the third quartile. So far, we discussed how to find the quartiles of a standard normal distribution. That is, the G-score values corresponding to the given probabilities 0.25, 0.5, and 0.75 respectively. Now let's discuss the general quantile problem of a standard normal distribution. That is, for any given probability P in the range of 0 to 1, we shall try to find the G-score corresponding to the given probability P. Here we shall discuss three possible types of quantiles problem. Quantiles corresponding to left tail probability, that is, probabilities given on the left side of the curve. We are trying to find out this quantile value. Quantile corresponding to right probability, that is, probabilities given on the right side of the curve. We are trying to find out this quantile. And the quantile corresponding to the middle probability. Here, the probability is given in the middle. We try to find out these two quantiles containing this interval. Here, we need to notice that the problems with left tail probability is easy to solve as compared to the others. Let's call it as default problem. So, any other quantile problems can be simplified by changing it to the left quantile problems. Therefore, our first effort in each case will be to change the particular problem into left tail quantile problem and solve accordingly. This is left tail. So this is right tail. Here we simply take the complement of this probability P, that is 1 minus P2. If we consider the quantiles corresponding to this probability 1 minus P2, this will be the quantile same as this. So this right tail quantile is changed to left tail quantile without changing its quantile value. Similarly, for this middle quantile, we take the complement of this probability P3, that is 1 minus P3, that is the complement. So we consider this as leftover. This leftover 1 minus P3 needs to be divided equally into two tails. So each tail gets the share of half of 1 minus P3. So this is the half of leftover on the left side. So this is left quantile problem. So this quantile value is same as this. So here we have this left quantile problem that gets this quantile value. Similarly, if we add half the leftover to this probability P, we get this whole probability and we get this quantile value, converting this whole into the left quantile problem. So this way we get these both the quantiles by changing the problem into left quantile. Let's consider these three examples with the given probabilities 0.38 on the left, 0.33 on the right, and 0.84 on the middle. Keep this left as it is, and we are going to change right and middle into left as follows. Complement of this right probability 0.33 is 0.67 is the left probability that results the same quantile as the right probability 0.33. Last, the complement of middle probability 0.84 is 0.16 that we consider as leftover. That is to be divided to both the tells. Each gets the share of 0.08. The tell on the left with probability 0.08 results the lower quantile of the interval. The complement of the tail on the right with probability 0.08 forms the left quantile with probability 0.92 results in upper quantile of the interval. We have changed all the quantiles into the left. Now we shall proceed to compute these quantiles using different methods such as R, Excel, TI calculator, GTable, and my website. First, easy one to start the process is to visit my website link here. This is the page. Select normal quantile manual. For standard normal, keep this mean and standard deviation as it is. In this text box, probability input for quantile, enter the given probabilities turn by turn and see the result on this display panel. First 0.38. Refresh. The result here, negative 0.3055 is the quantile for the left probability. 0.67. The result here, 0.4399 is the quantile for right tail probability. 0.08. The result here, negative 1.405, is the lower quantile for middle probability. And 0.92, the result here, 1.405, is the upper quantile for middle probability. Using R, the command is qnorm inside the parenthesis, probability, mean, standard deviation, lower tail, and log option. Since we are computing left quantile, we use only the probability values, keeping other default argument as it is. If we copy this command and paste at the R console and enter, we get the left quantile. If we change this to 0.67, we get the right quantile. And for Q norm, 0.08 gives the lower quantile for middle probability. Q norm 0.92 gives the upper quantile for middle probability. Using Excel, the command is norm in inside the parenthesis probability, mean, and standard deviation. If we copy this command and paste in any cell of Excel, we get the lower quantile. Similarly, if we change this to 0.67, we get the right quantile. And if we change this to 0.08, we get the lower quantile for middle probability. And last, if we change this to 0.92, get the upper quantile for middle probability. Using TI calculator. The command is inbnorm inside the parenthesis. The arguments are area, mean, and standard deviation. On the calculator, press two buttons, second and bars, and then 3 inbnorm. On the next screen, enter area, mean 0 and standard deviation 1 are default values. First, enter area equals 0.38 for left probability. That results this negative 0.3055 as the left quantile. Next, enter area equals 0.67, which is the complement of right probability. This results this right quantile 0.4399. Last, enter area 0.08 for the lower tail of middle probability. This output negative 1.4051 is the lower quantile of middle probability. Last enter the area 0.92, which produces the quantile 1.4051 is the upper quantile of the middle probability. And the last step, let's use Z table to find the quantiles. This is the Z table. In this table, we try to match the given probability with a number inside the body of the table. Then we read the Z-score corresponding to the match or the nearest match. This Z-score is the quantile value corresponding to the given probability. From the Z table, find Z-score corresponding to the probability 0.38 for the left probability, Z-score corresponding to probability 0.67 for the right probability, Z-score corresponding to probability 0.08 and 0.92 for the lower and upper quantile of the middle probability. Let's try to find these Z-score from the table. Let's try to match 0.38. So this number is the nearest match, 0.38209. Therefore, negative 0.3 is the quantile value for the left probability. Similarly, let's try to match 67. So this number 0.67003 is the nearest match for the probability 0.67. The corresponding Z-score 0.44 is the quantile value for right probability. Let's try to match 0.08. So this value 0.0806 or 0.07927 is the nearest match for this lower middle probability 0.08. The Z-score is negative 1.4. So the corresponding lower quantile of the middle probability is negative 1.4. Similarly, if we try to match 0.92, so this value matches the probability 0.92. Therefore, the corresponding Z-score 1.4 is the upper quantile for the middle probability. Now let's discuss quantiles of general normal distribution that we come across in our real life day-to-day activities. Consider these three examples. First, income per family follows normal distribution with a mean of $30,365 and a standard deviation of $8,220. In this problem, our interest here is to find the cutoff income for bottom 15% of the families, a quantile for left probability. Next problem, a test score follows normal distribution with mean of 65.8 and a standard deviation of 14.3. Here, we are interested to find the cutoff score of top 10% of students in a college. This last example is the price of previously owned vehicle follows normal distribution with a mean of $12,400 and a standard deviation of $1,800. Here, our target is to find the cutoff price to catch the middle 70% market. We shall find this value, the lower quantile of the middle probability, and this value, the upper quantile of the middle probability. This is the graphical representation of the problem. The first problem is the probability 0.15 left. Next, this is the probability 0.1 right, and this is the probability 0.7 middle. Here, 10% right is converted to 90% left, and here 70% middle is converted to 15% and 85% left, as shown in these graphs. Let's start computing these quantiles using R software, Excel, TI calculator, Z-table, and my website at this link. First, the easiest one, that is, visit of my website page at this link. This is the page. Select normal quantile manual. For the first left probability, mean is 30,365. Standard deviation is 8,228, and lower probability is 0.15. If we refresh, the lower quantile is 21,840. For the right quantile, mean is 65.8, standard deviation is 14.3, probability is 0.9. The quantile for right tail is 84.13. Last, for the middle probability, the mean is 12,400 and standard deviation is 1800. Probability for the lower quantile is 1.5. The lower quantile for the middle probability is 10,530 and the upper quantile is 0.85 and the upper quantile is 14,270. Using our software, the command is qnorm. The arguments inside the parenthesis is probability, mean, standard deviation, lower tail, and log option. If we copy this command and paste at the R console and enter, we get the quantile for the lower probability. If we change this probability 1.5 to 0.9, mean to 65.8, and standard deviation to 14.3, and enter, we get the quantile for upper probability. For the middle probability, for the lower quantile, we enter here 0.15. The mean is 12,400 and the standard deviation is 1800. If you enter, this is the lower quantile of the middle probability. Similarly, for the upper quantile, if we change this 0.15 to 0.85, we get the upper quantile of the middle probability. Using Excel, norm.in is the command with the arguments inside the parenthesis, probability, mean, and standard deviation. If we copy this command and paste in any cell of Excel, we get $21,837 and 23 cents, the cutoff income of bottom 15% of the family. If we change this to 0.9 and mean 65.8 and standard deviation 14.3, we get 84.13, the cutoff score of top 10% students. And again, if you change this probability to 0.15, mean 12,400 and the standard deviation 1800 and enter, we get $10,534.42 is the lower cutoff price of middle 70% of pre-owned vehicle market. If we change this probability to 85, we get $14,265 and 58 is the upper cutoff price of middle 70% of pre-owned vehicle market. Using TI calculator, the command is inv-norm. Arguments inside the parenthesis are area, that is probability, mean, and standard deviation. On the calculator, there's two buttons, second bars, and three inv-norm. On this screen, input area equal to 0.15, mean 30,365, and standard deviation 8,220. It returns 21,837.23, the quantile of the left probability. Next input is area 0.9, mean 65.8, and standard deviation 14.3. It returns 84.13, the quantile of right probability. Last, the input for middle probability lower quantile, area 0.15, mean 12,400, standard deviation 1800. It returns 10,534.42, lower quantile for the middle probability. Last, change the area to 0.85 and get 14,265.58, the upper quantile for middle probability. Use of z-table. First, we shall discuss steps in using z-table. In the first step, we read z-score from the z-table corresponding to the given probability. We already know this standard transformation. We solve for x in this standard transformation to get this inverse transformation, which is used to find quantile value. Let's browse z-table to read z-scores from the probabilities. This is the z-table. The nearest match for the probability 0.15 is 0.14917. The corresponding z-score is negative 1.04. Similarly, the nearest match for probability 0.9 is 0.89973. The z-score corresponding to this value is 1.28. Similarly, the nearest match for 0.85 is 0.85083, this number. Z-score corresponding to this number is 1.04. We apply inverse transformation on these z-scores to get the quantile value. Let's compute these quantiles. Corresponding to z-score negative 1.04, the quantile value is 21,807.88. Corresponding to z-score 1.28, the quantile is 84.10, and corresponding to z-score of 1.04, the quantile value is 14,272 here. So the left quantile is 21,807.88. Right quantile is 84.10, and the lower middle quantile is 10,548, and upper quantile for middle probability is 14,272. This is how we can find quantiles of a normal distribution using different methods. By now, we understand that the inverse normal distribution serves as a valuable tool in statistical analysis, risk management, and decision making. It enables us to quantify uncertainties, estimate unknown parameters by providing a means to convert probabilities into corresponding values on the normal distribution. It provides a useful tool for statistical analysis and decision making, and has wide applications in finding critical values for testing of hypotheses and confidence interval. It aids in estimating the likelihood of extreme events or tail risk, and helps determine the probability of exceeding certain thresholds and take appropriate action to mitigate risk.